next speaker is Felix Rieseberg, who has a particularly difficult task because he's the last speaker standing between you and Rieseberg of food that's going to be served outside. But I promise the talk will be super interesting and spannend. Sorry, I forgot the word. You know what I mean. Because it's about building apps with Electron. So welcome, Felix Rieseberg.
Thank you. Thank you. Thank you. Hi. My name is Felix. I'm here from San Francisco. I work at Slack, which is I'm not entirely sure. How many people here know Slack? Real quick. This is amazing. This gives me a good feeling. This is pretty good, given that we're still like a rather small company. Anyway, our mission is to essentially make people's work lives easier and more pleasant. We're basically trying to ensure that people who communicate with their team don't hate that, piece of communication. Nobody really cracked it so far, but working remotely and working in remote teams is like a pretty difficult task, and we're trying to make that better by building communication tools. And we happen to have one of those communication tools, and I'm responsible for building the desktop app, the desktop version of Slack. And the desktop version of Slack is built in mostly JavaScript, which is pretty much why I'm here, right? I'm trying to tell you and convince you that building desktop apps in JavaScript is a good idea. But it's a pretty common occurrence that I tell people who are building desktop apps in JavaScript, and you have two groups. You have the native developers on one side, and then you have JavaScript developers on the other side, and both of them are like, this sounds like a bad idea, which I can't really fault them for, because we had things like PhoneGap, which I think if you were able to produce a good app with PhoneGap, you were probably wizard. It was basically impossible to build a decent app with PhoneGap. It was slow, it was all kinds of terrible. But I'm here to tell you that even if you're not running Slack, you're most likely running desktop apps written in JavaScript. Electron has become pretty big over the last 2 years. Are there any users of either Atom or Visual Studio Code? This is less hands than I anticipated. Those are two amazing editors, and you ought to check them out. They're pretty good. They are written in JavaScript, but we have a ton of other, applications: WhatsApp, WordPress, Ghost Desktop. We have a decent amount of applications written in Electron these days, and that's like pretty much enough for me to now definitively say that you can build decent applications in JavaScript. And the key to that is, of course, Electron. Electron is essentially a combination of 3 core components. The first one is Node.js, the JavaScript we all like and love, including all the APIs that Node.js has to offer. The second one is Chromium, aka Chrome, which is essentially the way we render things and we communicate with something that looks like a user interface. And the third one is C++. And when we talk about these things, like something becomes very apparent very quickly. People generally like Node.js. Node.js is like a thing that I think now has sort of proven itself. People don't really question anymore whether or not Node.js is a good idea. You can write fast code in Node.js. It's working, it's decent. And we know that it's cross-platform, and it works well cross-platform. We know that Node.js works fine on Windows, macOS, and Linux. We got that down. Then the second part is Chrome, which at this point, as we all know, is basically an operating system. Every single time we build Electron, the actual package Electron, you don't have to do this if you want to run Electron yourself, but every single time we build Electron, our build machines, for whatever reason, need like more space. We're currently working on the next version of Electron, and our Windows build machine, which has like a casual 500 gigs reserved for the repo, once again ran out of disk space, because apparently Chromium is gigantic. But the good news is that Chromium is also a fantastic tool that runs really, really well cross-platform, right? If you want to support Windows, macOS, and then the individual store versions of both of those platforms, and then you have like a few Linux users, some of them using Debian, some of them using whatever else, right? Chrome tends to run pretty well on those platforms too. And then the third one is C++, and usually people aren't really like super excited about C++, mostly because C++ is difficult, you got to manage your own memory, it's like, all kinds of terrible. But C++ is like pretty much the best thing we have today when it comes to cross-platform development. It also tends to be the best thing when it comes to building applications that are really, really performant. If you want to build something that is blazingly fast, you're probably going to go and do it with C++. And the secret about Electron, in opposition to PhoneGap and pretty much everything that came before, is that you have that layer of C++ available to you. So if you're just using Electron and you want to write nothing but JavaScript, you get a bunch of APIs that do native stuff for you. You just call out to Electron, Electron goes and has like a native implementation of doing exactly that. And if you want to do it yourself, there's a ton of tools available to you that do stuff natively. Hannah talked about SQLite. SQLite is blazingly fast. SQLite can be used in Node.js. And it's blazingly fast because it is native, right? That's the whole idea. You have this native module, and then you have some bindings, and those tools get to work together. So long story short, you combine all those things and put them into Electron. So let me briefly talk about what Electron actually is. I have like 3 more slides, and then I'm just going to show you code. But there's like a decent amount of basics we need to cover. So the first thing is, whenever you start up Electron, nothing really happens. You basically have a node process. So if you're running on a desktop operating system, nothing really happens. You just basically run a node process. That's very similar to running node index.js. So Electron boots up, and at that point, Electron is really just Node.js with a new module called Electron, so you can call require Electron, and that gives you a host of APIs. And that is something we call the main process, because it doesn't have a window, right? There's no user interface, it's just running as a process. And that thing does 2 magical things. One is it's capable of opening up windows, and even better, it's capable of communicating with those windows and having those windows communicate with each other, which is pretty impressive, because that's the core feature for many web developers that they don't have, right? You can build decent applications in JavaScript. The main thing that is holding us back, and there's solutions to this on the website too, but the main thing holding us back is this whole like single-threaded thing, right? You have one thread. Good luck, right? In this case, you have as many threads as you need. So what you do is, as soon as you open up the main process, you get to open up multiple windows, as many windows as you need. And those windows are there on thread. They get to do all kinds of magic stuff. And you can sort of like fire and forget, which is pretty cool. So this inter-process communication is sort of like the key here. You get to have processes talk to each other. You can do native stuff on one thread and then do some other stuff on the other thread. And if we look at Slack, and if we look at how Slack is actually built, I don't really care about which framework people like, right? Electron doesn't really care. You can use whatever you want. We happen to be using TypeScript and React, and the reason we do that is because there's one big benefit to using Electron, in addition to everything I just mentioned, which is we have one browser, and we know pretty much exactly what the browser is capable of. Chris was talking a decent amount about polyfills and stuff like that. We don't have polyfills. We don't need them. Chrome 56 just hits stable, and it natively supports async await, right? Like, this is stuff that we're not going to be able to use on the web for a while, but we can already use it in Electron because we know exactly what the runtime looks like. We know exactly which APIs are supported and which aren't. And for us, I talked extensively about C++ and why C++ is important. The key here is that Slack is a messaging app. 90% of what we do can be easily done in JavaScript and HTML. And then there's stuff like video calls, which if you try to do that in JavaScript, in just JavaScript, you're going to have a bad time. Especially if you want to do it in like 60 frames per second, right? You can like use a canvas or something, but you are going to have a bad time. So video calls, in the case of Slack, are completely native. There's this giant native node module called Slack calls, and we just require Slack calls. And Slack calls goes and does its thing natively, compresses your video natively, makes sure that you're not wasting memory all around, and then talks with Chromium, which gets to consume essentially the memory, right? So that's pretty nice. I know this was like kind of dry, so what I thought what we're going to do now is I have this little demo of quickly building something like Visual Studio Code or Atom. And the reason we get to do that is mostly because if we look at something like Visual Studio Code, and if some of you have never seen Visual Studio Code, it looks like this. It's a code editor. It's like a giant window where you can type code. You know, just in case somebody has not seen a code editor before, you can type in it. It's kind of nice. Anyway, Visual Studio Code is essentially just a web application that somebody was like, what if we package this website and sell it to people as an application? Would that work? And the website they tried to package is something called the Monaco Code Editor, which is entirely open source. You can just go and use it. Does the exact same thing, it even has the whole it even has the whole autocomplete thing, right? AKA IntelliSense, and knows exactly what this thing is. So what we can just do is we can just take this and turn this into an Electron application and then give it native features, like saving a file, right? Which right now, from this website, if you have this script right here, you can't really save a file. It makes it very, very hard for you. You can like download a file, but can't really save a file. So, with that said, let's look at what an actual application looks like. Electron applications are, at the heart of them, just Node applications. They're just NPM packages. The one thing you might notice is that we have a def dependency on Electron, and then we have a start script, which just reads Electron dot. And this is pretty much it, right? We have a main file, just like you would in Node. So in Node, you would normally write node main.js, and that would do a thing. In the case of this main.js, it would do nothing because the file is empty. But in our case, we have Electron dot, which does very similar things. So if I just go into the main.js, say console log hi, and I decide to run this, this is exactly what happens, right? Which is sort of what we assume to happen from a Node application. The one big difference to Node here is that instead of doing this, I can go ahead and say const browser window. And I'm requiring that out of Electron. I can, of course, also require FS, right? That totally works. But the key here is that I can do this thing. And this by itself is not very cool, but what I can do is I can say, give me the application, which is the actual application object. And then I can say app on ready, let's do a thing. And that thing would be a new browser window, right? And if we run this again, ta-da, we have a window. This is sort of like a very sad state window. Chrome, for instance, Chrome never anticipated for Windows not to have any content in them. So if you open up DevTools, which you can do, they immediately crash because they're like, what is this? I'm not used to a page being, there's a window here, but there's nothing in it. What's going on? No, but for real, I mean, DevTools are amazing. So obviously the next step will be, I already have this index.html. I can just fill that with rando stuff like this, right? Fill it. And then we're just going to say, we do the same thing. We're just going to say main window equals this. We can give it a let, just to make more sense. I can say load URL file, which is local, right? That's cool. That's something we can do now. I'm just going to say index.html. So we can try this again. Let me close this. Pardon? You didn't put anything in the HTML? No, I think I did. No? There's nothing in the body. Oh, yeah, no, that's fine, though. To be clear, the thing that we're trying to do is we're just trying to give Chrome something so the DevTools start opening up. Because otherwise, if you give Chrome nothing, Chrome's like, this shouldn't exist. This is a window that this shouldn't exist. So if we run this again, still an empty page, but we can open up DevTools. And it's already complaining about style sheets not being there. But the cool part here is that I can now say require FS, and that totally works, right? I now have this super cool FS object that I can do things with. And I guess you can sort of like tell how we're going to go from here, right? We're now just writing Node code that runs in our browser that gets to do native stuff. And because we get to do native stuff, we can do cool things with it, which is kind of nice. So moving on. Now we're actually going to put stuff in here, right? We're actually going to go and fill our index.html with something. I'm going to add a container, and then I'm going to go ahead and probably abuse the internet here by installing Monaco using npm, which may or may not work. Who knows? It's fine. And what I'm going to do is my index.html, I'm going to give it a script, which I can already do. I can just say script, right? And because I'm essentially running Node here in this website, I can just do this, which is super cool. I can just say, that totally works, right? This is kind of nice. So if I make a new file and call it renderer.js, and I say console log, hi, and I run this again, and open up, ta-da, that's our stuff, right? That just works, which is kind of cool. So let me do a few things. Let me say const loader equals our Monaco loader. And this is like super exciting. I'm just going to I'm just going to grab the Monaco thing, which is Monaco. Now we have it, and we can do things with it. And what is happening here is that I'm basically just grabbing my container, which is now in index.html, taking the container, and then I'm just telling Monaco, hey, can you go ahead and just turn this div into an editor? Which right now is going to be rather small. It's going to be kind of small editor. So we're going to go ahead and actually create this style file that the DevTools kept complaining about. And that too is like pretty simple, right? Kind of easy. Nothing crazy. We're just telling the container to please be like full width, full height. And again, because we have Electron, we know exactly what the website looks like. I can just use like the viewport. I don't really have to worry about what this is going to do in IE7 or whatever. It's just going to work. I know what the features are, which is kind of nice. So let me make sure that this is correct. Cool. And let's try this out. The problem with live coding is that you never really know whether or not it works. But here we are. We can now, in theory, do things here. Var high equals high. And the thing already knows what this thing is capable of, right? I can already do things. We already have like something that looks and feels roughly like a code editor. In theory, since Monaco is open source, you could just like sell this as it is right now. Just go for it. However, this editor currently, in its current state, has one major fault, which is you can neither open files nor save them, which is sort of bad, right? And I have this super cool hello file right here, which is just a text file, and I can drag it onto the thing. But then, because this is Chrome, Chrome goes, you dragged a file onto this. You want to navigate to this file, which is not wrong. That is exactly how browsers should work. But in our case, we do not want to navigate, which again is something that especially spammers have tried to figure out in browsers for like forever. But we in Electron have full control of the browser, and we can just be like, this browser does not navigate. So navigation away from the page is impossible. And that's why I'm going to start showing you guys how to, first of all, communicate between the main process and the browser window. And then second of all, we're going to do some cool stuff and try to open this file, see what happens. So in here, in my main process, we have this main window. And the main window has a property called web contents. And web contents are essentially, it's sort of difficult to explain, but everything, if you think about Chrome as an application, you can think about each tab sort of like an iframe. It's not entirely correct, but it's very, very close. And that iframe has a set of properties that are not available to you as a web developer, but they are available to you as a developer. So web contents is a JavaScript object, and it has events like on will navigate. Right? That's thing. It's not available to you in JavaScript because if Chrome gave that to normal web developers, they would immediately like ruin things with it, like right away. Right? You would just immediately create a bunch of web pages that you can never navigate away from. It would be all kinds of terrible. But we in Electron can actually do this. So we receive the event and we receive the URL that this thing eventually wants to navigate to you. And the first thing we do is we're going to say no navigation. This is no longer happening. And then I'm going to kind of say console log the URL, which works. Let's start this again. So now, if I drag the file on here, nothing happens, right? And down here, we got the URL logged. So now we know it's file uses my name and then hello. So what we've got to do is we've got to ensure that instead of navigating, we don't navigate. That's something we already did. But then we also want to make sure that that URL eventually is sent to the actual editor, right? Which is in a different process. If you open up Task Explorer right now, you would see a different process. And by the way, if you ever open up the Task Explorer while you run Slack, you will see like 10 different Slack processes because we keep each of your team in a different thread and we like shut some of them down. And if you're not using Slack for a while or you're not using a team for a certain while, we're just like, unload that team. We can always fire it back up whenever you need it. Anyway, web contents, this is where the whole IPC thing comes in because now I can say, main window, web contents, and then I can say send. And I'm going to give this a channel, something like open file, and then I can give it the URL. Here we are. And in fact, because you can see right here that this is file, that's a Chrome thing. It's not really like a file system thing, right? So I'm just going to say URL slice 7 because I want to cut out the file. That's something Node doesn't really understand what that means. So anyway, this is now being received by the renderer. In theory, though, the renderer has to listen for it. Right now, can't really do anything. It's not going to receive this. It's not going to pop up in the console. It's going to be a native event that is sent to the window. So in order to receive that, I can use a thing called the IPC renderer. IPC standing for inter-process communication. There's a counterpart called the IPC main, which does the same thing for the main process. But what I'm going to do is I'm going to make myself a little file manager, right? Because we have modules, we can do this, right? And this file manager does a few things. The first thing it does is it grabs the IPC renderer from Electron, and then we grab fs from Node. And right now, this doesn't really do anything. You can call the file manager with the editor, and it's going to create a new class. So in here, let me require that, because again, this is just Node. So I can just say file manager, require file manager, there we are. I'm going to call this with the editor. There we go. And in here, in my open file, in theory, what I can do is I can just say IPC renderer on open file. I'm going to get the event. Actually, just do this. Right, just so you see what's going on. So actually, this doesn't work. I need to do this here. Sorry. Yeah, great, fantastic. Let's try this out. Let's start this again. I broke something. That's entirely fair. That's entirely fair. You can't call something arguments. That's not legal. File manager is not defined. What a lie. Oh, yeah, that doesn't work. Cool. We can just reload this. Cool, there we go. So now if I drag this file, it gets sent to the main process first, and then ends up in here, right? This being eventually the URL. So the first one is, what is the actual sender? And you can see it's like a JavaScript event emitter, but if you kept going up to this, eventually you would end up in the main process, and you would end up with the native IPC of Chrome itself. So what I can do now is I can grab this URL and read the file using Node, and then just attach it to my editor. So I'm going to go and do that. Open file. There we go. Right. And instead of just sending the args somewhere, I'm going to say e URL. I'm just going to call this open file with a URL. So what's happening is just a very simple, very dumb read file. And then I have the data and set the model on the data. Pretty straightforward stuff. And I'm sort of expecting it to be JavaScript, meaning that my hello script conv is probably not going to be accepted as well as JavaScript. But let's go for it. Let's drag it on here. Ta-da! Hello script conv, which, as it turns out, is not legal JavaScript. But again, this already works, right? You can do things. We could, in theory, keep going here. So I hope that you sort of understand the concept here. The cool thing about Electron is that this was like a rather simple example, but there's like absolutely nothing about Electron or building desktop as an Electron that in complexity goes beyond what you just saw, right? We could now go forward and build like saving a file, which actually let me just show you real quick how you not actually save a file. Let's just pretend that this would be saving a file. But let me show you real quick how you would, for instance, open up a save dialog, right? In Electron. It's amazing. So you have the remote object, which gets to call stuff on the main process. And here I can say remote dialog, open, show something, show save dialog. There we go. So now if I try this again, drag this in here, we would see a save dialog, right? It gets a callback, gets a callback with the URL, and then you can go and save a file, and so on and so forward. There's a few more cool things that you can do. For instance, one of my personal favorites is, you can just ignore all of this. One of my personal favorites is to configure the main window and configure what it looks like. So for instance, we can just set the title bar style. meaning, again, something that you can't really do with a normal browser. We can control what the actual window looks like. So if you see this now, it's like sort of hard to see, but we no longer have a title bar. We now have a custom window. And also, if you wanted to, you can make the window transparent, meaning that if you want weird window shapes, that is totally available to you. You know, maybe build the first chat app that is actually a circle. You can do it. Nothing keeps you from doing that. No, but for real, you can do all kinds of magic things. You can, for instance, add items to the menu bar, and that is where custom window frames really come in handy and do some cool stuff. Or like a typical example is Slack acquired a company called Screen Hero. And when you do screen recordings, one of the typical questions you have, not just as a web developer, but as like anyone doing anything that is supposed to record your screen is, A, how do I record the screen? But B, how do I do cool stuff? In our case, we want to do something that is along the lines of, I want to have an overlay for the menu bar, right? I want to drag a window right here. I want to take this window, which I can no longer drag because I removed the title bar. But you know that a window can't go here, right? With Electron, you can totally do that. You can just be like, hey, I want this window to be at the very, very top. I want this window to be atop the menu bar. All stuff you can do. So, going back to my little presentation, because I have a few more things to say. Not many, but 2 or 3 things. The first one is that the Electron community has grown quite dramatically, and we're currently tracking more than 1,200 packages that do amazing stuff in Electron. Talked about screen recordings just now. If you were to build a screen recorder that doesn't suck for macOS, that would be, first of all, great, because I badly need one. But second of all, there's already a module called Electron Screen Recording, where you just go, hey, Electron Screen Recording, take a video, and then in a callback, you just get a video, which is amazing, right? And you get that for all kinds of stuff. We at Slack, for instance, maintain Electron Spell Checker, which allows you to hook into native spell checking. Because, again, I talked about things that are sort of difficult to do in JavaScript. Spell checking is one of them, right? If you just imagine like an array with 20 billion entries, and you call it .find on that array. It takes a while. Natively, not so much. It's a lot quicker. And especially, those of you who use Slack may have noticed we auto-detect your language. So it's literally an array of like every single dictionary has a few billion entries. And we combine them all, and we're like, let's see what kind of language is matched. That is stuff you really need to do natively. And if you were to build an application, you can just require Electron Spell Checker, and everything automatically works for you. The community is quite fantastic because we have Microsoft so engaged with the Visual Studio Code. We have GitHub, who's in charge of the actual project, super engaged. We try to contribute some time. We actually, we're just 4 people. I said we're 4 people. We're actually 5, but one person just full-time works on Electron. Doesn't even have code access to actual Slack. Just Electron, nothing else. The second thing I wanted to talk about is that the way I just showed you how to do Electron is not really. What you may have noticed is that I wrote a decent amount of boilerplate code, right? I had like this package.json, and then I created a main window, and then I did all kinds of small things. If you were to actually build an application, if you don't want to do that, it's totally available to you. Many people do that. But if you were to build an application, you could use something called Electron Forge, which I think I have time to show you. Let me just open up iTerm. I'm going to go here. So what Electron Forge does and what you can do in Electron, which is pretty powerful. Oh, this is going to take forever. Sorry. What Electron Forge does for you is it sort of sets up your whole boilerplate and by the way, completely agnostic as far as your front-end frameworks are concerned. I know Hannah was amazing with like, what kind of framework do you prefer? We're not brave enough. So we just support all of them, which I think is like a solid approach too. Anyway, the key feature of Electron Forge is that it comes with something called Electron Compile, which again is a Slack project. We, for instance, built our application now in TypeScript. Not trying to start a war with anyone. We like it. If you don't, that's fine. If you want to use CoffeeScript or something, and it comes with something called Electron Compile, which will on the fly compile TypeScript. Modern JavaScript, in this case Babel, CoffeeScript, whatever you have, less stylus. And once you're ready to ship your application, it's going to cache going to cache the compiled assets and deliver them to your customers in a way where they don't have to recompile them. So you can do cool stuff right here. You can see that you can just import things, right? It's already pretty modern. And again, you can just start this. But the cool part here is that Electron Forge also automates all the stuff that is really, really hard. So I don't know if you noticed, but there's a few operating systems out there, more than I would like, because I'm the one who, whenever you get a new version of Slack, I'm the one who built those. And it takes me currently a solid week, because apparently Linux still needs like 50 different versions of applications. There's like, RPM, Debian packages, and then Ubuntu wants them signed, and they have like their own app store, and then they also have the Amazon app store, which is different. Electron Forge sort of automates this away for you, and you just say, hey, Electron Forge, give me packages for my application. And then this thing goes and does it. Because I used to work at Microsoft. Both Microsoft and Apple have this excellent habit of saying, we have a store. If you take your binary as is and put it in the store, we will not allow that. So you need to Slack in the Mac App Store is different from Slack when you download it, because Apple. Apparently nobody thought about that. And the same is true for Windows, because, of course, why not, right? So, long story short, if you want to try this out, maybe start with Electron Forge, because it's going to save you a bunch of pain that us, the people who started with Electron like 2 years ago, had to go through. And I know that people sometimes feel a little bit weird about black magic, but this is abstracting away stuff from you that you will never, ever really want to think about. Example. DMGs. DMGs are a nice way to ship your application. DMGs sometimes have a background. I wrote a Perl script, Perl, in 2017, Perl. Because with the latest version of macOS, Apple apparently decided to change the format in which DMG backgrounds are configured. They didn't tell anyone, so everybody just woke up one morning to, oh, I see the background is gone, nice. And as it turns out, Perl was the only scripting language embedded with macOS that is capable of building that DMG. So I spent like 5,000 lines of code, first of all, relearning all of Perl, and second of all, making this happen. Apple then 2 weeks later fixed their DMG, again, without telling anyone. The point here is Electron Forge is fantastic. By just going with Electron Forge, you're not missing out on anything you would actually need. And in summary, we're sort of like nearing the end of our talk. JavaScript on the desktop is pretty powerful. It's especially powerful if you write 99% of your application in JavaScript, and then the last pieces in C++. You don't have to write your own C++. Chances are that there are already modules available for Node which do exactly that, right? Hannah mentioned databases. I hope nobody at Ghost, unbeknownst to me, wrote like a lot of C++ to make that happen. But they ideally just went with SQLite and called it a day, because that was good enough, fast enough, performant enough, battle-tested. Millions of developers are using SQLite. That's just good enough. And this is probably good enough for your Electron app too. In fact, it's probably good enough for your application, all up, right? There's a bunch of native apps that use SQLite. The second point is the Electron userland, which is wonderful and magical. We have like all these companies involved. We even have like Box and WhatsApp providing a decent amount of open source code, which is quite fantastic. Also, Chris briefly mentioned Brave this morning, which is a new browser, also based upon Electron, which was cool because I ran the Electron meetup in San Francisco, and Brendan Ike, the drug-infused and crazed inventor of JavaScript, came by and spoke at that meetup about Electron, which was really cool, right? You're standing there and you're like, I owe my career to that guy, and now he's talking about this thing that I built that is very cool. So if this gives you any confidence, the guy who invented JavaScript is now building his new company on Electron, which I think is like a pretty good testimonial. Yeah, and the third one is, to get started, don't really do anything crazy, just use Electron Forge. And in final summary, I'm on Twitter. I will, in a minute, tweet out both the slides as well as a cleaned up version of that thing that I just showed you, the code editor. That's a cleaned up version, and it's on GitHub. And it has 8 commits. I even implemented saving files in a proper way. And if you were interested and you want to check this out, it should be fairly easy to follow along what I'm doing, because the end result has, I think, 100 lines of code. But that ideally should give you an idea of how to build Electron apps. Yeah, that would be pretty much it. Thank you very much.